The next topic is about the homogeneous linear differential equation with constant coefficient. Here's the way to find the solution. Like I said, now we are going to take a look at the homogeneous equation. So the fx, which is on the right hand side of differential equation, is equal to 0. And this time, which is that we are talking about the constant coefficient. So the coefficient a0, a1, a2, a3 to an are the real constants. It's a constant, it shouldn't be the function of x, okay? And the method that we are going to find for the solution of this type of differential equation, we say that because it's the order n, so how many solutions of y that we should be able to find from this differential equation? N solutions, right? It is assumed that if we can find y1, y2 to yn, and then all y, 1 to yn, are linearly independent to each other, then y is equal to c1 y1 plus c2 y2 plus c3 y3 plus until cn yn. At this point, you understand, right? And then, but how can we find y1, y2 to yn? The way to find this is that we assume that y is equal to exponential of mx. So this is the way that we are going to find the solution for homogeneous linear differential equation with constant coefficient. Okay? We assume that y is equal to exponential of mx, where m is arbitrary number. It could be any number. By this definition, you should be able to find n value of n. Let's see why we get that, okay? Because we assume y is equal to exponential of mx. So the next step that we got to do is that we plug this y, because if it is the solution, then when we plug it in there, it should vary with this equation, right? So we are going to do differential of y for n time. The first time what we get, the first derivative of y equal to m exponential of mx. The second time equal to m square exponential of mx. And the third time m to the power 3. Then I let you guess the n time is, you see, the first derivative you get m. The second derivative you get m squared. The third derivative you get m to the power 3. So the n derivative you would get m to the power n. Then you just plug everything here back into this equation. Let me put number 1 there. For example, this is the equation 1. We put y and derivative of y into equation 1. We would get put this as equation 2. When you look at the equation 2, you see each term in here have exponential of mx, right? So I just take it out. Now, in order to make this equation right, can exponential of mx equal to 0? If exponential of mx equal to 0, make the whole thing equal to 0. Or if the term in the parenthesis equal to 0, also make this equation go to 0. But which one that we should use? If we use the first one, which is exponential of mx equal to 0, that means our y is equal to 0. Does that make sense that the answer of the differential equation equal to 0? You can't use anything with that answer. So we got to take the other way. Exponential of mx shouldn't be 0, can be 0. So in order to make equation 3 satisfy, the term inside the parentheses got to be equal to 0. Equation 4, we called it auxiliary equation or characteristic equation. We are going to use this equation, the equation 4, to find m. How many values of m that we should be able to find from equation 4? Can think about it. For example, if we have equation like this, m squared minus 3m minus 10 equal to 0. How many values of m that you can find? 2, which is what? Right? You would find 2m. So m is equal to minus 2 and m is equal to 5. So now, if I have this equation, like equation number 4, how many m values that I should be able to find from equation 4? N value. Now, n is equal to 2, you have 2 value of m. So if n is equal to n, any n, you should find n value, right? From equation 4, we should find n value of m, right? And then from our assumption, y is equal to e exponential of mx. Now we have n value of m. So that means we have how many y? We have y1 is equal to, right? And you have y2 is equal to and you have y3 is equal to exponential of m3x, and you have yn is equal to exponential of mnx. So you find n solution of y. But anyway, it just depends on the root of equation 4. The root of equation 4, we can divide it into 4 cases. The cases that the case that I talk about it right here is case number 1, which is m is the real number. The n is the real number, and these numbers are not repeated. Or we can say it's a distinct number, distinct real number. Case 1 we call distinct real root.